In this video, let us talk about the scatter plot, the line of best fit, and the correlation coefficient. If there are two variables x and y, then there is an effective way to find a relationship between the two variables by displaying that in a graph called a scatter plot. And if you would like to find how closely they are connected, maybe we can fit a line called the line of best fit. If we are interested in finding a numerical value for the relationship, you can find the coefficient, which is your correlation coefficient. To understand this more clearly, let us take an example. In this example, we have the number of tornadoes during the year 1950 to 1995. Let's prepare a scatter plot and see how they are related by drawing a line of best fit, and then using the line of best fit we can predict some values. Now in this example, the number of tornadoes are the values which are response variables. We are using the year to predict the value of the number of tornadoes, so the years will be the explanatory variable. Years goes along the x-axis, the number of tornadoes goes along the y-axis. So using those values, we can easily plot those scatter plots by taking that as the coordinate points. So the points are scattered all over, so we have the scatter plot. Now, the scatter plot will have a line. We can represent all the scatter plot using a line, which is called the line of best fit. The line of best fit will be used to predict the value of unknown values which are not given in our question, maybe outside the region or within the region. And also we must remember that the line of best fit will not pass through all the points of the scatter plot. It will be a best representation for the data, but it will never pass through all the points. So in this case, maybe we have the trend line like this. Maybe in other clips I can show you how to get the trend line. Suppose if this is the trend line for the year 2015, in our data the values were given only from 1950 to 1995. We are trying to find the value for 1915. So for 1915, 1200 will be the predicted result. So if the trend continues, then you can say that the number of tornadoes reported for the year 2015 was 1200. The same way, if you are interested in finding the value for 1972, you can easily get the results using the graph what we have. The scatter plots will provide a convenient way to check whether how strong these values are, how closely connected they are, in which direction they are, and a numerical value will be calculated that is called a correlation coefficient. This coefficient will be positive if it is in the positive trend. That is, as x increases, y also increases, then the coefficient will be positive. As x increases, if y decreases, then the coefficient will be negative. If the points are scattered all over in your scatter plot, then it has no relationship at all. That is, it has no correlation coefficient, or it has little correlation coefficient. And the coefficient always lies between -1 and +1. We have three different diagrams here. In our first case, as x increases, y increases, so it will be positive. The second one, as x increases, y decreases, so the coefficient will be negative. Third one, it is scattered all over, so it has no relationship or it has little correlation. If we are fitting a line and if the points are close to the line, then you can say that it is strong. For example, let's take these 4 figures, in my first diagram, I can fit a line and the points are not close to the line, but they are on the positive side. So it is a weak positive correlation. Whereas in my second one, the points are close to the line, so it has a strong positive correlation. Third one, as x increases, y decreases. So it is negative, but points are not closer to that, so it has a weak negative relationship. The last one will be a strong negative relationship. Let's create a scatter plot here, and for that scatter plot, let us try to find the line of best fit. So to start with, let us have some points scattered all over here in this diagram to get a scatter plot. And for this scatter plot, we would like to get the line of best fit. So let's select the line of best fit. And for the lines what we have here, the equation is y equals negative 0.225x plus 3.65. So the regression line has a slope negative 0.225, and that's what we are seeing here in this diagram. Now if we are interested in finding the regression line for this, let us prepare a list. So the points whatever we have has to be selected under a list. GeoGebra has selected that as L1. So for this, I would like to find the correlation coefficient. So the correlation coefficient is for my L1, and it says it is negative 0.168. So when the slope is negative, the coefficient is also negative. That's what we're seeing here in this diagram. Now in this diagram, suppose if we are moving these points, see, this is negative. The slope is negative. Suppose if I am trying to move these points like this, see, it looks like I have a line which is coming almost horizontal. You see, the equation changes. As I move these points, the equation changes and the coefficient also changes. See, when it has a negative slope, it has a negative slope. When I move this, it becomes positive slope. See, at one stage it becomes 0 and then it goes to positive. See, now it becomes a positive slope, and when I change these points, see, the slope increases and also the correlation coefficient also increases. And suppose if the points are coming closer and closer to this, see, you get that the coefficient is 0.905. Let's see this set of points here. It looks like these points are lying on a straight line. So this scatter plot consists of points which lie on a straight line. And we know that it doesn't have a slope. So if we are trying to find the line of best fit, we cannot define the line of best fit. So let's see what happens to this. We are not able to do that. So let's find the coefficient, the correlation coefficient, and we have to find the list first. So let us prepare a list for these points here. That is our L1. So if we are trying to find the correlation coefficient of this set of points, L1 here, the coefficient is not defined.